Yeah, hello everyone. We'll kick things off now. So please excuse the poorly photoshopped GDC badges on top of these slides. This was originally a talk I gave at Unreal Fest, and I was editing these slides on a plane. So I got rid of all the Unreal Fest branding. Now it's a GDC talk. My talk today is going to be about basically navigating Unreal Engine source code, why it's important, how to do it, and some hot tips for kind of exploring the labyrinth, as I like to call it. So yep, let's skip that one. My name is Ben Carnall. I've been working in the games industry in New Zealand for about 10 years now. I started way back when as a lecturer at MDS actually, and then worked at Aurora 44 and Ashen for a little while before boosting to an AI studio, working on graphics pipeline stuff. And then I worked at Rocketworks, working on Icarus as a tech director and eventual CTO. And then now I'm at a place called Omni Creative Products, which is a bunch of ex-Epic and Fortnite guys making their own game. And the whole reason I've put this up is because my whole career so far has been either focusing on architecture or like low-level technical systems. So full tech rat, running in the pipes, figuring out how things work. And I think one thing that we've lost sight of recently, I guess, is that the blessing of being able to look at the source code in Unreal Engine, even though it's intimidating, is like the main reason we wanted to use it in the first place. I remember Unity, and like you'd have a problem in Unity before, like you could buy source code access for like $2 million or something. Well, I used to be able to, but still, you know, it was a headache when something went wrong. Whereas Unreal, you can literally just go find out what's happening. So that's the premise. Just quickly, why it's important. I'm a very strong advocate for developers when they work on a feature, they're more confident about more pieces of that feature than they are unconfident or lacking in that feature. And if you do have a lot of time on your hands in pre-production and you know the basic premise of what your game's going to require or the technology it's going to require or the pieces that you're looking into, I think it's really important to do an initial search on engine source. But also, whenever you get a feature request, if you're not confident, make sure you schedule some time into your tasking to actually look into whatever features you're going to leverage in the engine. Understanding the feature means that you'll be able to help get that brain and game idea into the game quicker, and also you'll be able to understand like the kind of dangerous path that feature might lead you down. Yeah, I mean, also, like, it just helps the scope. Unreal is, you know, everyone's had these problems where someone will engage a tick box, or they'll activate a feature, or they'll activate a setting, and then all of a sudden your frame rate goes to 10 FPS, or they'll make some change to some world composition setup, and then your nav mesh breaks, or you've got like thousands of physics bodies all of a sudden, and you don't really know why or how this frame rate problem has come up with, or why it's so buggy. But ultimately, if you start looking in the source code, you can pretty quickly find the source reason for any of those issues. So instead of sitting there freaking out, toggling tick boxes, I'd strongly recommend starting to dive into the source code. So when you start looking at Unreal source, it kind of looks like that. There's all this lovely, pretty front end that looks really nice. You got blueprints, you got all these fun features, you got all these ViDocs coming out, all this stuff that's like use RVTs, which are very cool, but they're all bells and whistles. And then when you start to look behind the curtain, it looks pretty intimidating. And even though this is a pretty dark monitor, there's also a giant monster in the back there. That giant monster in the back is if you stay in the light for too long and you just pull these things together and make this really pretty thing, eventually that monster comes out and Unreal starts to work really poorly. It doesn't have to be that way. All of those great features that you see in those promo reels can be used and leveraged in your game effectively, but you have to understand them first before you can use them properly. The other thing as well is that intimidation usually comes from a sense of it's not my backyard, or these are like super pro programmers and developers making epic source code. How am I ever, literally epic source code, how am I ever going to be able to understand it? But I just pulled these comments randomly before I made these slides, and it's just like everyone else's code. To do finish, this doesn't even work, and then obviously the classic encapsulation issues. You know, these are just regular programming mistakes, and you'll find them in the source code as well. It's just people's code. You can totally disarm the fact that, you know, it's some holy grail. It's the same as the stuff you would have been writing in your own frameworks potentially. And in fact, at OCP, I work with the dude who wrote Slate. He's the CTO of the company, so he wrote one of the core systems in Unreal, and he is more irreverent about that engine than anyone else I've ever met. He'll be like opening up and be like, man, this thing sucked. I wrote this 10 years ago. I don't know what I was thinking, you know? And so when you get to hear that, it also helps disarm that kind of holy grail. Admittedly, though, the engine is amazing. It is doing top tier end work, but it isn't like, you know, some kind of Pandora's box. You can kind of piece it out and look at it just like any other engineering problem. So the first thing to step to understanding Unreal source is that everything's a module. So everything in Unreal is the module. Your game's a module. All the different key pieces in the engine will be a module, or they'll be bundled into a module. And all you need to know is it'll be some C++ code that's supported by some C# and some additional tooling to help create a reflection layer so your code is understood by the engine and vice versa. That's how you get things like blueprints, being able to reference native function calls. It's how you get, even in code, all of the Unreal C++ magic, it gets supported by this structure. So when you are investigating and digging down, know that sometimes you'll be looking at a particular module and there might be some things that are locked off for you. And the really important thing is that when everything's a module, the engine has to define the relationships between these modules. It has to know when and how to include each module, just like linking old libraries or DLLs back in the day. It's exactly the same thing, but it looks slightly more intimidating, and it's got this weird build layer that you don't really want to look into. But there's some pretty key hallmarks you can look in the source code to figure out what you're working in. The two types of module you'll be mostly concerned with, there's about 7, I think, and they're trying to reduce that down to some more key archetypes. But the two that you'll interface the most is probably runtime and editor. Runtime basically means it'll be available in your cooked game, and editor means it won't. And editor specifically means it's only available in the editor. And when you get asked to do a feature where it'll be like, hey man, we need to bake out static meshes at runtime as part of our game because we've got like an object creator or a factory that's pumping out like cool combinations of things, you'll soon try and start pulling static meshes and cooking them, and someone might make this huge awesome network of stuff that does exactly that, but it only works in Pi when you play an editor. And then when they cook the game out, it's completely broken. So the key thing to do there is whenever you're like looking around the source code, if you see with editor or you look up the module that you're working in or looking in, you'll be able to quickly find out if that source code is a good reference point, but ultimately a waste of time to try and implement. You know, if you're trying to like implement those interfaces in runtime code, you'll just create your own headaches. So let's begin. When you're about to dive through a dungeon, it's important to have good adventuring gear. And for me, there's no best tool in class. I mean, I've got my preferences, but ultimately the thing is comfort. So if you're comfortable with your tool set and you understand the key bindings to help navigate around quickly, because with Unreal, you got a lot of modules and you got a lot of interfaces and you got a lot of like data objects, and you're going to be constantly bouncing around all over that code base. So if whatever like the IDE you're in, make sure you're comfortable to just like find all results, quickly pop around there, open multiple tabs, pop out search histories, literally work on your workflow, which sounds funny as a programmer, right? Like we don't really have a lot of workflow chats for programmers. There's plenty for artists because it's really important. For programmers, it's, I think, equally important because when you expedite that process, you can look at more code, you can understand the code easier, and you're less intimidated to start diving around. So my adventuring gear is I use Rider for Unreal Engine. It's a show of hands, who uses Rider for Unreal Engine over VS Code? Yeah, cool. It's easily the best IDE I think so far for Unreal because it gives you, like, even in reflection inspection where it'll tell you where functions are being referenced in blueprints. It's got really quick parsing and indexing of the source code. It lets you do things like regex searching of the entire code base really quickly, which is insane. So you can do like string literal searching, which is going to be a key feature of how to navigate the source code later in this talk. And the other thing that the head of engineering at Rocketworks introduced me to, which is this orange magnifying glass on the side called Everything. It's a tool by Void Tools, and it's effectively a super quick file search, for like everything search for a Windows system. So you pop it open, start typing in a file name, it'll automatically pop up all the results in that thing. It's basically what Linux users wanted for Windows this whole time. I'd strongly recommend. It's got a great GUI, and Unreal obviously pumps out a bunch of artifacts. You're always looking at log files or binary executables, or if you're trying to use one of the tools but you don't know if you've built it, you can look for like name.exe and you can see if you need to run that build path. So yeah, super valuable. Another thing is Unreal's got some inbuilt tools that are super helpful. Obviously Insights is a performance and profiling tool, but it can also be a code inspection tool. And the reason for that is that I'm going to use this example and take you on a little journey with just this example here. Basically what I did, so you guys know, is I made a physics body, like a character run around with way too many physics bodies on its skeleton. It's pretty simple. When it was running around and even just moving through space without actually animating it, we met with all these update overlaps. And normally, the cautionary tale of premature optimization, this is kind of more of like a metaphor to help you to pull something through the source code. But when you see that, you could logically deduce that, hey, there's probably a bunch of physics objects in the scene, or there's a bunch of colliders in the scene, and we can figure out what that is pretty quickly. But I would strongly urge you as an engineer who probably, if you guys remember making your own collision code, you can go and find their collision code. There's like 7 steps between this point and the end, but you can still go find it. And once you're done with this talk, you should be able to find it for any of the systems in the system. So taking this example, I wanted to find out where update overlaps actually did work. I don't mean like preparing data and passing it through interfaces. I wanted to go see where like the shape collision math was. And I also wanted to know that whole chain so I could understand where that data starts, where it gets manifested, and how it gets passed through the whole thing. So I literally just looked for that stat. I went, sweet, update overlaps. I can do that string literal search I said before, and I found pretty quickly that there's cycle counters called update overlaps. I found out where it's called everywhere, and it was in 2 places. Scene component and primitive component. The scene component method was pretty empty, so you didn't need to worry about it too much, but the primitive component had some cool stuff. So immediately we look in there, and eventually you'll find this component overlap multi, and I'm like, hell yeah, sweet, this is going to be the do function. You go in there, and it's not. All it's doing is preparing some data, and then it's calling this overlap multi on body instance. And I was like, cool, what's body instance? Body instance is an ustruct, that obviously holds all the actual data for that collision set. Cool, let's go into body instance overlap multi. We go in there, and then at some point in the method you see this large like physics command execute read. So for me that's like, okay, perhaps there's going to be some state running on some kind of physics layer that may not be in lockstep with the main thread, and we're going to need to figure out what's going on. But thankfully, looking through, you can find another geom overlap multi. So we're going to go into another interface. This one, specifically the physics interface. It's like, sweet. Then we get in there, and now it's using chaos interface, and this is where the actual collision code was. I had to just go through 6 steps to find that, right? Bit annoying, but ultimately, that led me to understand a pretty key pattern for how Unreal source code is structured most of the time. I'm going to present some pretty general kind of abstractions of this space, but usually in Unreal Engine, you'll have actors that consist of components. Those components have the logical code that prepares data that gets packed into some struct that gets sent to some interface that'll then get abstracted onto a particular target platform and then do the actual work. The reason that Unreal is structured this way is because it's a general engine. Back in the day, if you're making a very specific engine or if you're just hacking some code together, you can make something for a particular platform and someone was like, hey, can that go on Switch? And you'd be like, no chance. Unreal thankfully supports all of that and multiple RHIs or like rendering engines for you to shift around on. And so that's why they've created this whole do stuff to data, pack data, send it down to my low-level thing that's doing the same stuff that we would have done for our core frameworks. When you get to that do something code, some of it's pretty amazing. There's some cool math in there and some magic, but most of it is what we're used to doing, which is like writing graphics submissions or doing AABB testing or something simple like that. And that's, you're going to see this all over the engine. So what we just saw was an actor with a primitive component that had an F-body instance sent to a physics interface, and then chaos did its thing. Drawing a static mesh, you have an actor that has a static mesh component that has a scene proxy data struct object that gets sent to the RHI command list, which is their interface for the RHI, and then it starts working with that data. What's really cool about this is you can swap this out for anything. If this was, say, a render target and you wanted to figure out how you can read from a render target, like doing like a pixel readback, figuring out where it actually gets the pixel data from and what the GPU is actually doing, it'll follow a very similar structure to this. Oh, look at that. This is actually where I found that out, where you'll find sometimes it might not be all the way down to some abstracted interface layer if it's not like a core function like physics or rendering or networking or I/O, but it's part of their own objects. You'll still see the same pattern. The way that landscapes update their height map data inside of, or like their geometry inside of the editor, is the landscape proxy actor will have a landscape component that reads from a render target, passes it to a landscape edit structure, and passes it off to a bunch of edit code. It's literally the same pattern every single time. They're obviously simplifications, and they can create breadth and variation across these patterns, but once you understand that, like, oh, I'm just looking for a struct now. Like when I'm now working in the engine and I want to figure out where something's going, I stop kind of looking for components and I start looking for the named structs inside those components. I do a find all usages, like Alt-Shift-F and write it, and then all of a sudden I can see where that struct is being referenced. Most of the time it's encapsulated inside that component. Very rarely will you see it accessed by things outside of that standard interface pathway. So you don't have to be worried about like, oh man, if I change it here, is it going to like screw up 33 other things? They'll probably do a copy at some point. You'll be able to start moving it around. There'll be some protections for you. So one of the key things is if it's not a component, it'll be an interface subsystem or manager object. So the components do things, but there's also like high level blueprint function libraries and subsystems that do things, but they'll always end up packing into some kind of data structure. And just like before where I said, hey, a logical guess is that there's too many physics bodies in the room, you'll only likely be concerned with the interface up to that interface code, because if you build in debug as well, which I'd actually recommend some people do, debug game or development is fine, but if you need to figure out what the engine's doing, building in debug is great because you can break. So I could go to where that thing passed off its body instance off to like before, like 3 interface calls up, before it passed it down to the endpoint chaos physics system, and I could literally just see the shapes inside that rigid body structure and be like, oh, there's 3,000 shapes in here. And that would have been super easy to be like, oh, probably have less shapes on this character. Yeah, and so the other thing that's kind of crazy that happened to me really early on is that because of this like heavy polymorphism and interface abstraction and then separated across modules, IDEs get confused and they hurt themselves in their confusion. So if you try and do like a go-to definition declaration sometimes, it'll totally break. It just won't work. Like on that body instance, when I went to like go to like the declaration of this object, it totally failed and it just like my thing like spooled up and then broke. But instead, when I just looked for it by using like find all usages, it immediately came up and works great. Or just doing like a string literal search. So don't give up if you try and do your regular key binding and it doesn't take you there. There's other options you can take in your IDEs to get to the source code you need. Yep, I mean, the other thing too is when you're going down these like long pathways to find out where something is doing something, it's really good, like I said before, to find general usage of those things as well, because you'll get a better understanding of what's going on. And again, like I spend most of my time finding an object, Alt-Shift-Fing on the object, and then looking through a list of all the ways where it's referenced and called. Most of the time you'll be just looking at like validity checks and like making sure things are not null, and they're pretty boring, but you'll find pretty quickly some key on like operational areas where they're doing work on that data. And like I said before, if you're ever like super lost but you know that thing's being called, just break the code. and build and debug. Don't be afraid to waste some time waiting for it to compile. It'll give you that key debug information that you need to be able to actually identify what's in that structure, what values are there, and that can be super, super helpful. My favorite thing about doing this is collateral learning. So almost all of the cool features I've ever actually managed to make was only really a product of me screwing up a feature in the past. So like having something break horribly and looking into it in depth meant that next time I was like, oh, I actually spent a lot of time looking in the wrong area in the code base, and I know a lot about that. So for me, understanding how that f-render target system works ended up helping me with some dynamic mesh work. So I needed to have a landscape that could be manipulated at runtime. And I spent a lot of time looking into the landscape code and recognizing that the landscape code is not where you want to do that. But thankfully, because I spent this huge deep dive, I wasn't intimidated about where the landscape was getting its data from. And then I was like, cool, all of this pipe up to the point where it's packing a data structure and then sending off to this interface, this code I didn't want. All of that, super valuable. And then I basically just did the same thing. I literally stole, because it's open source effectively. I literally stole that how to get render target data and affect a large scale multi-component mesh, because that's what a landscape is, right? It's like a huge thing of like multiple landscape proxies and all different types of meshes, and that was super valuable. Back at Aurora 44, we did make on Ashen. It's a peer-to-peer networked game, right? But an Unreal Engine, like peer-to-peer, is not really a thing. It's a listen server approach, right? So you've got this authority management that you've got to deal with, and we wrote this huge layer where we had to figure out how to make it so that there was some kind of like authority sharing across two peers. And I spent a lot of time looking through the replication code, which was very valuable. But by looking through the replication code, I learned about their reflection code, which is even more powerful in Unreal Engine. By looking at some of these key areas, I understood what if fields were. I understood why a class default object's important. I understood not only why it's important, but how to iterate through it. And for those of you who don't know, the class default object, the CDO, and these if field, if property things are all of the data that gets constructed by that build graph I talked about before that creates that reflection layer between your C++ and Unreal. And once you know this, you can break all encapsulation straight up. Like if it's a U class, you can literally iterate through any property on any object and ask it for its value. You can just be like, hey man, that thing that's very precious to you, I want all your data. This ultimately leads to us being able to create our behavior and action system in Icarus by being able to bind delegates automatically, by having similarly named delegates, getting information out of those and archiving and serializing them, which led to the ability to create a huge like data table entry grid where we could specify arbitrary behaviors for weapons and have them just like hook up automatically. So designers could be like, cool, I want a boomerang that does poison and then comes back to the player, and they could make that all in their tiny little blueprint without making any interface bindings or anything like that, and it just worked for them. And so if I hadn't done this, that would have been impossible. Or I would have been like, sure, and then screwed it up, So code waypoints, how to get around the engine sometimes just to find some pretty key things. Like I said before, stats and command lines are super useful. So if you've seen a stat group, you can go find what that code is scoping, which is super important because stat groups tend to be around stuff that actually does things. So that's an immediate way to figure out what's going on. Command line stuff is cool too. Have you guys ever used, like when you're trying to debug something, you're like putting in like show flags and stuff in the engine? You can go find out what that show flag actually leads to doing, because you can string a literal search for that show flag and its actual text. It'll be in text somewhere in the source code. It'll be hooked to a variable, and then you look for the results of that variable, and bam, you're now looking at the RTX GI code, which is how I figured out how to do RTX GI for Icarus as well, which didn't really work, but I got it there good enough when it was really early. And the only reason I could do that is by using their stat commands. I was completely lost as to where that code was functioning or how it was working. The stat commands helped me a lot there. The command line helped me a lot there. Blueprint function nodes as well. If a blueprint function ever has a readable name, you can find that name. So if you're transitioning from blueprint mostly into code, you can actually go see what those blueprint nodes are doing. Now, cautionary tale, Kismet libraries are really good, but they are utility functions. They shouldn't be like the fundamental building blocks of your code base, but it does help you remove yourself from that blueprint debt. And if anyone's worked with Unreal long enough, you know that blueprint should be at the end point abstraction. It should be like the lightest layer. Don't make your glue or your foundations in blueprint, because not only will that become a huge problem for debugging, but when you upgrade engine version, which ultimately will happen, someone will be like, hey man, you're on 4.14, let's get to 5.2 like in a week. And you're like, okay. But again, all the stuff that I talked about before makes that so much easier. And yeah, obviously, like when you look into their Blueprint Kismet libraries or any of their accessible like endpoint abstraction code, you're looking at Unreal code made by engineers using the interfaces the way they want you to use them. Because again, when you're working with source code, right, you can go read the comments, you can go see some like hierarchical examples, but if you've never seen them do stuff with their code, you might be doing it wrong. And it's a really good way to just make sure you're doing things the right way. I mean, it's just like really convenient things. You'll be like, oh, I didn't know they added a templatized version of Get component. Not saying that happened to me, but you'd be able to go look in that code and find out pretty quickly the latest and greatest of how to work with the Unreal C++ source. Cool. This is an example of exactly what I was talking about. Shadow quality, you find that it's bound to a variable which you can then bounce around and look for the rest of it, and the same thing for that blueprint function. And that's actually how I started my how to import height maps from reader targets journey. I literally looked at the blueprint node and then followed the daisy chain of stuff all the way through. Cool. So yeah, now I'm stoked, because when I open up my suitcase, which is Unreal Engine, I'm not like, oh shit, there's horror in there, it's Pandora's box. I'm now stoked because I know my way to move around all this treasure. Because again, it's like, I don't know how big the Unreal Engine team is, but they're full of top-tier engineers making top-tier code, doing really cool endpoint feature work, and we can look at it. You know, when I was a student, I would have literally not killed, but I would have definitely sacrificed a few limbs to try and get that kind of information. Because, you know, I just wanted to learn as much as I can, and now we can. And again, cautionary tale, don't try to learn everything. Learn some specific things in a row. Make sure they're applied in a valid way to the work that you're doing every day. And in that sense, it's also really important to define your intent. When you are in the middle of crunch time where you're working on features and you've got some crazy bug and you're like, okay, I've exhausted all my regular options, I need to look into the source code. Really important to identify the problem that you're working with and chase that strand as best you can. So for me, just recently, I'll talk about this in a second, but I needed to update vertex attribute data on a dynamic mesh, which is like, should be super easy. I mean, back in the day, I was like, cool, I'll just make a vertex structure with some data, I'd tell the RHA what to expect, and it'd be available in my shader, and I'd be super happy. And I was doing that. And then I was accessing vertex color in my material, and nothing was happening. And I was doing it exactly like I would do it for a static mesh. And I was like, what the hell's going on? So I thought to myself, cool, let's go through the process. Static mesh component has an fscene proxy where I know it does the vertex attribute updating. I'm pretty sure dynamic mesh has the same thing. So I looked into dynamic mesh, found that they have an internal data structure, dynamic mesh 3, that then gets passed up to a scene proxy and updates all its stuff. And in there, I was like, hey, attribute, where's attributes? There's nothing coming up. And then eventually I looked into the just bulk post-edit update scene proxy object, and very quickly I found out where it was trying to pack its data, and that's how I found out about dynamic attribute sets, which is a whole new way to abstract attributes from your objects. And I'm not going to talk too much about it, but it took me 5 minutes to find this, as opposed to what would have probably taken me an hour or 2 hours beforehand. And immediately I was like, cool, solved my problem, and I started pumping color data into my meshes, and I was super stoked. And then so was my tech artist. So yeah, that's basically a very quick crash course on how to navigate Unreal Engine source. And I like to leave the end of this talk for a lot of questions and Q&A around particular problems that you've had or particular pieces of source code that you want to have a greater understanding for. So please ask some questions. Yeah, thank you. Sweet. Any questions?
There is like 20 minutes of questions. You can ask a lot.
Yeah.
What would you say is the quickest way to, say, easily get debugging in Unreal, say, source engine, and like, say, breakpointing and seeing data? Like with you, how would you go about doing that?
So for me, I would basically look through those interface tools until I got to the point where a data structure is being either populated or sent off to somewhere else. In build and debug game, you do need to download engine source for that. You can't do that by just pulling down the binary engine. You need to go and get their git and clone that and check it out at least. And then chuck a breakpoint right there, and then run your game, and then it'll hit that breakpoint, and then look at the data structure in your regular IDE inspector. Yeah, and that's kind of. Sometimes that even the debugger will get confused again, like because of all the heavy polymorphism and the abstraction. The Visual Studio debugger kind of broke a lot, and you need to get down like specific visualizers for Rider to make sure you could look at maps, and T-array sometimes would break. So every now and then you'll hit some problem where it's not visualizing properly and you can't see the data. And if you do a quick Google, someone will be like, oh, download this NatVis file and everything's fine. So that'd be the only catch for that one. Yeah. That's it.
What is something that you really want tech artists to know?
Oh, dude, good question. I think tech artistry is in a pretty interesting place because Unreal can give you the power to make beautiful things, but also that's usually where you find most of the performance slowdowns when they tick all these boxes. So really it is whenever you do enable like an Unreal Pretty feature or some kind of visual feature, it's doing the same thing, which is going and looking at the documentation of that feature, maybe looking up a YouTube video around like what that feature does and how it works. Don't expect tech artists to go look into the source to figure out what's going on, but I do expect them to understand the ramifications of those choices, especially because when you are mastering tech artistry in a particular area, it should be not only the ability to create beautiful things, but also the ability to understand how that beautiful thing works to a certain extent. So if someone comes to you and says like, hey, I want fireflies all over the forest, and you go, cool, you don't make a particle system where each one's a point light. And then it sounds very simple, but that's like a genuine mistake that happens a lot of the time. And that's totally fine, because ultimately you want people to brain to game to make pretty things. But tech artistry requires a bit of that workflow mastery as well. And yeah, I think ultimately also profiling your own stuff is pretty good too. Just setting up like a basic routine where if you do make some significant changes to a level or a map, or you do something, you actually create either a profiling scene or you profile the scene that's being included in. Sometimes you'll be in a studio that's funded enough to have automatic testing and does like an automatic perf test, but you can't rely on that. It's better to be like, oh, I made this thing and now the level's running at 10 FPS. I personally think there's no real good excuse to like commit work and then the playtest is running at 10 FPS. If it was just your change that did that, you should have been able to figure that out by pressing play in editor and flying around, or maybe even making your own build. So those would be the two major things. Cool. Sweet. Awesome.
If you had to learn UE again, for the source code that is, what would you do? Like what pitfalls would you try to avoid?
Awesome.
Had your memory wiped?
Mm-hmm. If I had my memory wiped, I'd probably very quickly look into the relationship between actors and components. How things are constructed is really good. Like that's something that a lot of people, I didn't include it in my talk because it's got its own whole ball game, but figuring out what happens when you spawn an object, or figuring out what happens in code when you spawn an object at runtime versus what happens at compile time. Because all of that cool reflection generation and CD object stuff happens well before you even press play. So that would probably be the start for me, is actor components and their construction path. And then once I know that, you're kind of looking at the start of the generalization of the whole engine. Because, the engine was built way back when for, first-person shooters, arena first-person shooters. And you'll find a lot of code that's basically just like, hey, let's make an arena first-person shooter as fast as we can. And things all being dependent on actors is also kind of, a flow-on effect of that as well. The fact that an info object is also an actor is pretty funny to me. The fact that it needs like a scene transform and all that stuff. So yeah, that'd be where I'd start.
I have a question. Can I ask a question?
Totally, absolutely.
Cool. What is the weirdest, most load-bearing thing you found in the Unreal source code?
Oh, good question. Probably the landscape code, not gonna lie. It's pretty convoluted. I guess the reason for that is because the landscape code is a legacy system and it was made well before module relationships existed. So, I said there was like runtime and editor modules. The landscape code is a runtime module that has a whole bunch of if editor compilation stuff in it, and it's pretty dense. So that would, not so much it's weird in how it's working, but it's weird in the fact that it's still working. And they wrote it like that in the first place is understandable. It's like, damn, I'm surprised they've been able to maintain it that well. Because, we've now got scene partition, which is awesome. And that seems to work well with the landscape code underneath as well.
To be fair, landscape originates in UE3.
Exactly. That's what I'm saying. Yeah, it's a legacy piece of code. It's just being built on top of. But yeah, that's probably the thing, is seeing that monolith. But that's honestly rarer and rarer these days in the engine. The modern code sets that are coming out in Unreal are awesome. The mass entity system, that's not something you should start with, but it's definitely something you should learn. The mass entity system on Unreal is very powerful. Similar to Gas in that it's slightly convoluted, but I'd say Mass is more impactful in what you can achieve in the engine than, say, Gas is for improving your workflows for designers and data object manipulation. Both very, very important, but there's some stuff that people can do with Mass at the moment that's like literally blowing my mind. Because you can make things like high-scale games where you've got thousands of things running, and it's thousands of things running really fast, and it's doing it. So you can have like a whole village simulation running. If you think about the classic Unreal game, it's not like a huge high-fidelity City Skylines type deal, but you could totally make that with the mass entity system in Unreal now, which is very cool. Yeah.
So my question would be, what would your rule of thumb be where, when you're trying to work out an error, at what point is your sort of like flag where you go, okay, time to go to the source code?
Honestly, just as soon as my first 15 or 30 minute work pass doesn't pan out. So like as soon as I've tried some things in Blueprint, or I've tried some options, or I've changed some interface around and nothing's working, I'm like, cool, I need to now understand more about this before I can make some calls. Because I have done some things where I've fixed problems and I've fixed them incorrectly. And all I've done is like stem the bleeding, but I'm just, it's not really solved the problem, and later on it all blows up. And if I just done the engine source lock in the first place, things would have been fixed a lot quicker. Now, it's important to also time gate that time, because, you can get kind of... not addicted to it, but you can get pretty nerdy with it, or at least I do, where I'll be like, oh, look at this, oh, look at this, oh, look at this, and I'll kind of, be like squirrel the whole time. So it's good to kind of hallmark that time and try and write down your intent, figure out what you're trying to work out, and then give yourself an hour to do that. And then like write down, if you especially when you're first starting off, write down what you found out in that hour and be like, did I answer my question, or did I just figure out how like chaos physics works now? Well, not figure it out, but at least read it, So yeah.
Hey,
Hey man.
what would you say is the right time to make a change to the source code, and what are the pitfalls and benefits of that?
It's now time to make a change. I would actually say that changing Unreal source code should be very, very specific and very lightweight. I'm actually not a big fan of changing source code at all, really, unless you find a specific bug or deficit. And usually as well, if you ever do make engine source code changes, just make sure you wrap it in some kind of like comment markup that's like, for us, it's OCP change begin and OCP change end. Because when you do that, engine upgrade is the only time it really bites you in the butt. But when you do that and you get like this huge change list diff and you're like, where's our code? Having those comment markups is super powerful. But yeah, I mean, we've done quite a bit of, all the places I've worked, we've done some version of engine changing. But ultimately, we either rolled it back because they fixed the thing, because it was just a bug fix, or we found a different way to work with the engine that was actually more in tune with what the engine was expecting. And that's, again, one of the powers of source code investigation, is that you get a much firmer understanding of how you're supposed to work with that thing and where you're not supposed to do that with that particular thing. And yeah, that's basically it for me, is if you are changing engine source, take a step back, have a look around, maybe find out where that thing's being used and be like, oh, maybe I shouldn't do that. But, if you're making like an internal sphere, like gravity system, then I guess, you've got your own problems.
Sorry.
Yeah.
Just a little thing. If you are changing it because we broke something, doing a pull request, if it is like fixing something, doing a pull request means that it's now our job to maintain your fix. So everybody wins. So please consider that.
Totally. And there's also so many times you'll fix a bug and then you'll like get the latest version of Unreal and they've done the exact same change you did. And you're like, I could have had my name on the like pull request list for Unreal. I should have let them know, Cool. Any other questions?
Any other questions?
Yeah, just a question about plugins. Let's say you create a plugin, and then for some reason, some code in the editor module, you want to port it to the runtime. What do you suggest to do in this case?
That's a good question. I feel like anytime you're looking at editor module code and you want to port it somewhere else or make it runtime accessible, you're going to like pull out an organ and all the other organs are going to come with it. Because, well, it depends on how well defined those module barriers are, but you need to look at something pretty... As an example, let's say you wanted to do that bake out static mesh thing that I talked about before, and you want to make baking out static mesh as a runtime viable thing. You're now going to be pulling out a lot of like very core code, and instead I'd probably argue it's better to find out where the baker starts and then writing your own abstraction of that kind of top layer. So where all that data preparation takes place before it gets sent off to an interface. Most of the time, that interface boundary will always be code that's available everywhere. But the stuff that happened before that, all of the data assembly and grepping, that's where all of the editor or runtime separation is. Because basically the main reason for that is that I want editor data. So I want stuff that they don't care about cooking down into an optimized format. But the do things stuff that happens at the bottom is almost always available. So instead of porting, I would look at what your original feature needs to do and constructing the pieces that you really need to do. And if you've got no other choices, then... I guess I've always had a cautionary tale. Like every time I've tried to do it, it hasn't worked well. And I had a really good tools engineer at Rocketworks, so I ended up just being like, "Hey Ryan, have a look and do it yourself," which isn't a great answer, but it's the one I think that is the safest. Yeah. Cool.
Just a follow-up, small question. Is there any sort of similar issues with the Kismet library for like material structuring, like custom nodes and using HLSL and stuff like that within post-processing?
Yeah, totally. So you can write custom material nodes, and all it is, it's a graph builder. So if you've ever written your own shaders, then you'll know that the way that works is you're writing basically chunks of instructions for a particular set in the graphics pipeline. And that material node graph that you're looking at isn't just like all happening at the same time. Like some of it will be compiled into the vertex shader, and some will be into fragment shader or whatever. And you can inject very specific things that take place in there, and it's totally fine. I would kind of... we've made some custom material nodes in all the places I've worked as well, and they've always been for very specific things. So as an example, that attribute data pack I just talked about, it isn't just vertex color. We're also using like the additional UV layers from 2 to 7 to pack all this kind of data, like wet density data and all this kind of landscape biome data. And we wanted to make that power materials, but we didn't want our tech artists to be like, UV index 3 up, like V is dirt. You know, we wanted to have this thing that could sample it out into named pins. So that's obviously a very simple node to make because it doesn't really do anything smart apart from reference different data. But all the way through to like, I worked, well, Sam Preble, is he here? Sam Preble here? No, he made a material node that was like, some sick like water underneath the, like when you bounce up and down underwater and you mix some kind of plane, it creates this really cool effect. And that we ended up having to pull it because it was just a little bit too expensive. So you want to like play it safe on those as well.
So is there any load-bearing sort of issues with like nested material functions? Or,
oh yeah, totally.
Like
so if anytime you work with material nodes, you'll see a material instruction count at the bottom, and that's the main thing that you want to look at. Material instruction counts aren't all equal though. You can have like a material instruction count that's super high, but they're all very lightweight instructions, and then you can have a very small material instruction count that's all heavy instructions, and that can only really come from understanding what those material nodes are doing. In terms of like cautionary ones to avoid, I think Chris at the back of the room would be much better to talk about that stuff because I ended up just like looking at instruction count and profiling it, and that's all I do. So
gotcha.
Yeah.
Thank you so much.
But please bother Chris later. He'd love to tell you about expensive things in the engine. Yeah. Yeah. Sweet. Any other questions?
Maybe Rider fixes this because I haven't used it. Reflection for the build and target CSs. Like normally in Visual Studio, you don't get anything, and it's real hard to sort of get back to the module rules and the various enums and things you have available. So do you have a solution for that?
Yeah, so I guess for me the solution for that is it is hard to, well, those C# files are effectively declarative and they're not functional really. They do have the ability to provide some simple like logic checks, but they're not really where you do stuff. The thing that does it all is the Unreal Build tool and the Unreal Header tool, and also the cooker, which I just talked about breaking an engine source, but you can make debug versions of any of those tools and look at what they're doing. And that's probably the main thing I'd recommend. If you're ever wondering why your reflection's broken or why your cook's broken, so many times we would run the cook in debug mode and then put a breakpoint where the assert was taking place and figure out what was busted. Yeah, that's a really good way to do it. And it's also how you find out that some random like material tree, tree piece is something wrong with it, like a pin wasn't plugged in and it's causing the cooker to freak out. Very rare, but it does happen. But for the UBT and UHT, it's really all you can do. Look at the declarations, look at the documentation, and then break in the UBT or UHT. Yeah. So the UBT, by the way, the Unreal Build tool effectively figures out the build graph and all that logic and module relationship, and then the Unreal Header tool is the thing that actually does the reflection and generates those .h files that pumps out all that cool generated code. Yeah. Cool.
Just out of curiosity, what's your biggest pain point with construction time stuff, like trying to construct components and the fun errors you get with that?
So my biggest pain point was trying to figure out how to do runtime components and make them work well. So like runtime component construction, because in Blueprint, right, you can go add component and you try and look and investigate what that's doing, and you find out later that it's not actually creating a component at runtime. Well, it is creating the endpoint, but it's baking out some static data somewhere, and it's all part of this like crazy construction flow. And that took a little while for me to understand what was going on. But once I understood that the way that you spawn components at runtime in native and the way that Blueprint spawns components at runtime are totally different. And that's really the only time where I've been like, oh, this is a bit uncomfortable, but the same thing? Yeah. Oh, yeah, there you go. And like, obviously they've also improved a lot of their runtime component spawning and all that, so they kind of they didn't fix the problem, but they made that less confusing. And I'm talking about when it was like 4.2 all the way through to 5.2, so a lot's changed in that time, but originally that was the thing that was like, how do I make this thing? I just want this at runtime and native. I was getting really angry, and then I looked, and then it was super easy. So that was a problem. But and again, that was how we did the action and behaviors thing for Icarus weapons. That was all components that got spawned at runtime and assembled dynamically on an object. Yeah. Cool.
Any other questions? No?
Sweet. Awesome. Easy. Cool. Thanks, guys. Really quickly, though, just a shameless plug. If you guys want to work with awesome people, we've got jobs. Please apply. This is an old list. There's a new list on the website, ocp.gg/jobs. And it's a very cool studio. It's probably some of the coolest tech heads I've ever worked with. I've been pretty blessed. I've always worked with awesome tech people, but some of the guys, my boss worked on like Doom Eternal and Doom, which is pretty sick, So I'm like, hey man, what have you worked on? He's like, Assassin's Creed, Odyssey, Doom Eternal, Doom. I was the lead engineer on Dead Space. I'm like, awesome, just those? That's cool. So, yeah, you get to meet a lot of cool people. Thank you.